Hi there, I'm TexasTim.dev, and thanks for joining me today. This is my continuing quest to grind through all the algorithm problems on LeetCode. I've done all the easy, except for sometimes they add a new one, and so I pick that off, and then I've done all the easy again. I've done about 15% of the medium algorithm problems, and I've done 3 hard. I'm trying as much as possible to work from easier to harder to sort of build my skills as I go. So without further ado, why don't we get on in there and see what we have today. So head on over to problems, algorithms, difficulty. Let's see if there's any easy ones. I kind of feel like a medium today, but let's see if there's any easy. There are not. There's just this kind of contest calendar one. So let's head over to medium. No, I don't vet these ahead of time. I do sort by acceptance. I work from highest acceptance to lowest. Okay, problem set somehow got turned off. Okay, algorithms, difficulty, medium. There we go. There we go. Status, to do. There we go. I need to bookmark that. There we go. I'll call this LeetCode medium. Okay, so interesting. Sometimes I look to see, so it's sorted by acceptance, which is how I do it. But sometimes I do look at frequency, and I'll go down a little bit to pick one with higher frequency on the premise that that might be because it's got a higher frequency of appearing in job interview questions. It's probably more interesting to watch, and it's probably more helpful in terms of maybe if you're trying to work that problem and you want to watch this video to kind of see how I approached it. So why don't we look down, and I'm just going to cherry pick. When I'm doing it by myself, I just grab the top one, and who cares? But for today, for right now, why don't we grab this really high frequency one, K closest points to origin. Let's do that one today. Why not? Let's see what we got. 973 medium, K closest points to origin. Given an array of points where points I is an ordered pair, which represents a point on the XY plane. So we're given a list of points, well, an array of points to be specific, and an integer k, return the k closest points to the origin. Okay. And we also return an integer array. So I've seen sometimes they give us an integer array, but then they ask us to return a list of integer. I guess they can do what they want. So far this is feeling a little bit easy. We're kind of going to be measuring the distance, and I already have an idea for a way to kind of optimize that a little bit. We're going to have to measure the distance of all the points. We can't get around the fact that we have to look at all the points so we can determine the k closest ones to the origin. So we're going to have to traverse all the points, and then we just got to return the k closest. So I'm thinking we traverse the input points, and we determine their distance or some metric that is related to that to kind of hint that I have an idea. The hint is that I'm not trying to be cryptic. So as you may know, the Euclidean distance is the difference of the x coordinates plus the difference squared. So the difference of the x coordinates, and then you square that quantity, plus the difference in the y coordinates, and you square that quantity. And then you take that sum and you square root it. Well, squaring is easy, and it's all integer. Because it's an integer array, so we're going to be given integers. But the square root that you would perform to get the Euclidean distance itself, very expensive computationally. And so what I'm going to do instead is just keep it as the square, which an ordered list of the squares of the distance of all the points is going to be in the same order that the square roots of their distance would be in. So why go to the extra trouble of, performing floating point calculations to get the distance when you don't have to go that far? It's, it'll shave some operations off of our algorithm. So that's the little shortcut that I plan on using. It's the only shortcut I have so far. Okay, in terms of sorting, some options there. Priority heap comes to mind, or priority queue, which the implementation of Java's priority queue uses a heap for sorting it. It wants the points. Let's see. The answer is guaranteed to be unique. And there could be 10,000. Let's see, 10,000. Yeah. It could be 10,000 points, and they could be from negative 10,000 to positive 10,000. I'm trying to think of how we'd want to sort these. One thought that comes to mind is to create a map of the squares of the distance to the point. And then I could also make a list of just the squares of the distance, sort that list of squares of the distance, because they're just integers, and then get the k closest points, and then look up in my map the ordered pairs associated with each square of the distance. That uses a lot of memory. But what it enables me to not have to do is if I don't go that route, then the other approach that occurs to me is to use a priority queue and write a custom comparator, which could also be done. I think let's try the map and the list approach. So we will need a map, integer to. Ooh, can I have a? I think I can put a integer array inside a map. I'm not sure though. Let's find out. Okay. This would be square of distance to ordered pair. Equals new hash map. I wonder if there are multiple points with the same distance. This won't work. Okay. So in that case, I would have to, I guess I will have to do a list of lists. That's fine. That's fine. So this will be a new hash map. I think that'll work. Nested data structures are always... Let's just see if this compiles. I'm missing a... Oh my goodness, I didn't mean to submit it. I just wanted to run it. Okay, it compiles. Oh my goodness. Okay, so that will work. And then I'm also going to have a list integer. And what would be a good list implementation? How about, I think linked list would not, because you got to always traverse the list from the head to get anywhere. So let's do array list. Okay. And now let's make a function. Square of distance that takes, and then a ordered pair, and that's all. And let's just call it result. Isn't that the computer science joke that naming things is one of the hardest parts of programming? All right. Result is going to be, oh no, we need two. Yeah. If you find my mind, let me know. I must have lost my mind. So the result is going to be the pair 1 x values. Let me make sure it's squared, right? Yeah. Let's make it a little more obvious. Pair 1 x minus pair 2x value, and the difference of the y will be these. The result is going to be diff x times diff x. There's our square. There's our square of that one. And then, actually, we can just turn that. Why not? Diff x times diff x squared plus diff y squared. Okay, so we got our square of distance. I think it's time to traverse. So each pair in points. We won't even have to use k yet. That'll come later. Okay. So we're going to do a couple things here. First, we have to get the square of distance. You know what's funny to me is that so we're always, I mean, it's always from 0. So why not just hard code that in? From 0. If I was worried about, you know, extending this later, you know, maybe later, maybe at the next iteration of this code, it won't always be the origin. It could be, you know, some other point. But then, you know, there's that that acronym YAGNI, Y-A-G-N-I. You ain't gonna need it. And the idea, that principle is don't don't jump the gun and start implementing functionality that you don't currently need, because, you know, requirements can change, or you get pulled off the project, so it's up to somebody else to finalize it, and they've got to, you know, work with what you started, and that's not always easy. So that principle of Yagni says don't over, you know, try to extend your program to account for test cases or conditions that are not currently real. They're just possibilities. So we're going to do square of distance from 0, and we'll pass in one pair. And I accidentally opened DevTools, and so it's going to be, we're not even going to need that. We're just going to return itself squared plus, so return the x value of the pair squared plus the y value squared. Okay. So now we have square of distance from 0. And now we have that. So we're going to add this value to two places. We're going to add it to squares of distances. So it'll be in there. And then I just realized if I store with the map, if I store it as integer, if I store it as each ordered pair as a list of integer, I'm going to have to convert it back to an array, because that's the type that that this class k closest has to return, is an integer array, an integer array of the integer arrays that are the ordered pair. Why don't I forge ahead, even though it's a little bit wasteful to move all those point values from integer arrays into list of integers and then move it back out? Why don't I forge ahead, and then we'll get it working, and then I can always go back and, you know, make it a little bit better. So this pair and then we'll add the x value, and then add the y value. So we've added this square of the distance. Now we get to associate this distance with this ordered pair. And actually, under the idea that we could have multiple points with the same square of a distance, I got to put in a little bit of logic. So we are going to wait. So I'm going to fill in the logic in that if block, but since I had this the name of the map already in my buffer, you know, my control C copy buffer, I figured I'd just drop it here and get it situated. So we're going to get the list of lists of integer associated with that distance. We're going to add, we're going to add this pair. Okay. Now what we need to do is find out if, and there's going to be an else. So if the map already contains this square of distance from 0, as I'm moving around, I see what people always criticize Java for in terms of variable names. These are some long variable names. They're super clear, but it's like, writing in COBOL up here. All these super long English words, variable names. Okay, if it contains, actually, let's do not contains, because then I won't need to do anything. If it doesn't already contain this key, and I guess I gotta check if it contains this key. If it doesn't contain that key, then we are going to create an empty list and add it. So list, and we'll make it, what are these going to be? Array list. And then we're going to put it there. I think there is like a, with maps, they have some fun methods. There's like, there's get or default or put or default. And there may be a method, for in hash map where you can maybe consolidate some of this, but for clarity and logic, plus I'd have to go look up the API, which I totally don't mind. I just don't want this to be, this video to be an hour long. So I'm just going to put in the code here and just kind of do it myself, of checking if it contains the key, putting in an empty list if it doesn't. And so we're going to put in our new list. So now, if that square of distance from 0 wasn't present, we've now populated the map with that square of distance and an empty list. So now when we come here, we're always going to be able to add it either to a pre-existing list that was there or to our new list that we just put in there. Easy peasy. Actually, let's start putting in some comments. I don't know, data stores, why not? Okay. Oh yeah, we want to get that list and then add. Wait. Add, what am I? Yes, no, that's right. We want to get this list and then add this pair to the end, and it'll still have the key value will be the square of a distance from 0, and then we're just adding an additional value. Okay. For a second I thought I had mixed up my gets and my puts or my adds. All right, so we populate our data stores. Now we sort the ordered pairs, which will be very easy to do. We can just do that. Let's see. Array list. I'm curious if there's a sort method and if there'd be any. Yeah, I don't see one there. Collection. So here there would be. How did it go all the way down there? Oh, I must have clicked twice. Okay. Sorted. Oh, that's the interface. I thought I was right. This is like a static API. Yeah, here we go. Sort. You can provide a comparator, but we don't need to. Although sort, yeah, actually we don't want to, because sort will order from lowest to highest, and we want the closest ordered pair, so those would be the ones with the smallest square of a distance. So we actually do want it in ascending order. So perfect. All right, so sort the ordered pair. Oh, no, actually, we're sorting the squares of distances. Okay. K closest points. Well, and I guess we also know we can create our return integer K and 2. And I always like to note that that's what we're going to return. It just helps me to be vigilant and aware of, what I'm doing with it, since that's what I'm returning. Okay. What I'm thinking about is that the K closest points are not necessarily going to be the K smallest squares of distances. Because, for example, say we have, 100 points. And suppose we want the 10 closest points. Well, there could be 10 ordered pairs that all have a distance of 1, and thus a square of distance of 1. And so I would only get 1 square of a distance. I would just take the highest one, because that's going to have 10 points in it, and that'll satisfy the requirement. So what I'm thinking I'm going to do is go one at a time from least to greatest of the squares of distances, and see how many points there are in that list, add those ordered pairs, and then when I get enough, I'll be done. Now, what I worry about is that suppose, let's say it wants the 10 closest points, so K is 10. What if I've got 9 ordered pairs with a distance of 1, and thus a square of a distance of 1, but then I also have 10 ordered pairs that have a square of distance of 2. So it's easy to get the 9 ordered pairs with a distance of 1, but then when I look into the next available list of points, I've got 10 that are all eligible, but I only need 1. So it's possible that they've set up the test cases and constructed the test cases in such a way that that won't happen. They might have thought ahead to that. Or it could be about to bite me unawares when I find out. But I mean, that would always be a problem if your K points, if, up on that boundary, for the kth, farthest away point, if there could be multiple possible correct answers. And maybe, let's see, does it say anything about that? It doesn't. It says they can be in any order. Why don't we forge ahead, as I'm so fond of doing, and we'll just find out what happens. All right. So we need K points. And how many do we have so far? 0. So now we want to go through the squares of distances. Moment of truth. Let's check our check our map. So that's how many there are. Now let's add them. I might not need to get that number. I might just blindly add them. So this would be, instead of so far, I mean, it will end up being how many ordered pairs we've added to our result array so far. But let's call it index into result, just to be a little bit more clear about what it is. So we want to go through each ordered pair in this list here. And actually what we're going to do is we're going to go ahead and populate our result array. Oh, let's cut it. Okay, let's make a little bit more room here. Oh my goodness, don't you just love Java? No, not there. Okay. So now we're populating our result array with, oh, hold on here. Yeah, we need this here, and then we're just gonna get each pair. There we go. Got a little too excited there. Okay. So there we get the X and we get the Y. All right. And what we're even going to do is as we populate the Y, we'll increment. And that way we keep, obviously moving on to new, actually, I want to make it just a little more clear. Okay. And then we're ready for the next one. Actually, I keep changing my mind here. Let's see if we're done. All right, okay. Got like 10 thoughts in my head at the same time. Let's do increment our index, and then we'll just check if it's equal to k. And this is assuming, oh, wait. We got to check outside the for loop. So this is me assuming that we won't ever hit the end of our result array in the middle of a list of ordered pairs that all have the same square of a distance from the origin. I'm assuming. That might be proved wrong, but we'll see. If they don't care, if there's multiple ordered pairs that have the same distance that could fill in the list of k ordered pairs, then I'll have to change this logic around. Actually, why don't we just move it up into there? So after every ordered pair we store, I check to see if we've hit k. And let's see, could k even be all of them? Yeah, so k could even be all of them. So yeah, why not just check after each pair we add. If index into result is k, that means we've filled up the whole array. result. I'm going to do early return, so we'll just return result. Some people are not well, I say some people. There are some purists who are not fans of early return because they hold to the idea that a function or like a method should have a single point of entry and a single point of exit. Some people think that, and so they balk at an early return. You know, one of the things they might say, and I just heard I was reading Wikipedia the other day, and so I came upon an article on programming paradigms, and so that's why I was reading about this. But the idea is that you have single point of entry into a method and a single exit, and one of the reasons for holding to that pattern is that if you have any kind of code or cleanup, you know, that has to happen as you're leaving the function, it's too easy to maybe only include that code at the return at the end of the function or the method, you know, where you might normally exit. And if you've got an early return, you know, in the middle somewhere, that it can be harder to remember to add that cleanup code, you know, up there in the middle of things. You know, if you have to like delete an object or deallocate memory, which isn't an issue with Java, but with some other, you know, with like C or something, you'd have to worry about that. So anyway, that's what I read. It doesn't bother me. I mean, for me, for performance, if I've got my result, get out of there. And I think it's very clean and readable. So I guess there's differences of opinion on that. Now, what if I go, so this will always, whether I have a K less than the length, if I have a K that is less than the number of points, this will work. If I have a K that's equal to the number of points, that will also work. So we will never complete the outer for loop, because even on the very last loop of the outer and the last loop of the inner, that would be where we'd exit. So down here, I'll say return result, but I'm going to notate shouldn't ever reach here. Will early return from inside nested loop above. Okay, I think this will work. Should I hit submit? I think so. Let's run it. Oh man. Oh, okay. Well, I should have looked back over my stuff here. Yeah, we got to make it that'll just make a linked list. Let's check for any other dumb mistakes, like a missing semicolon or trying to instantiate an interface. Let's try running it now. Ooh. List integer. Oh, interesting. Okay. New list. Oh, okay. Right. There we go. New array list of array list of integer. I think that's what I'm going to have to do. Right. It's a list of lists. It's a list of ordered pairs. Let's see if that works. Oh. I really want to read a book about, because I get this wrong a lot. Usually you can put the interface on the left and then the actual class is on the right. But for nested collections, in my experience, Java complains if I don't put the actual class on the left and right side. So interesting. compatible types. Can't be, so I guess I gotta put it up here too. Okay, where's this pair? All right. Oh, okay. Well, let's just use all array lists. See, it's like this ripple effect. Okay. Yes, it did work. Let's try one of the other test cases. So that they gave me example 1. Let's try example 2. Got 3 points. And k equals 2. Let's try that. It did run. Thank goodness. I think we should submit it. Hooray! Man, it's slow though. Look at that. I'm in the 10th percentile. But it does work. Okay. I might see a little bit. Ooh, that is small. But let's make it a little bit bigger. What are we doing? 125 to 150. Okay. Might shrink this. Will it let me shrink it all the way? No, it will not. Full screen. Huh, it gives me a little more room. Why not? So, can we make it faster? I'm doing a lot of storing. So there is a lot of overhead associated with objects like lists. So an alternative would be to keep it all in arrays. Or at least the squares of distances wouldn't have to be an array list. Because it's just a list of numbers. And we know there's k of them. I know the length, so why don't we... And then I'll need index into this. Which will start at 0. Increment it. Actually, I don't know that I need to store that value. I think that's fine. And then we add the pair to the array list. And I had talked about maybe instead of adding these array lists, adding integers, integer arrays, int arrays. So maybe that'll be the next thing I try. Square of distance to ordered pair. Okay, then we would sort this, and then that would actually be the same. I think this will work now. Now I'll have to refer to this. Make sure I don't. Oh, actually, maybe I should not increment it yet. We'll increment it as we leave. There we go. So here's a little bit of kind of cleanup code in here. Speaking of cleanup code, oh, I gotta do it on all of them. Oh my goodness, why is everything opening? Line 24. There we go. No, not. Okay. Except not this paren. Oh my goodness. Why did it reach 2? At line 16, there's each pair start at 0. Let's see, this test case has 3 points. Squares of distances. Oh, well, this may not be related, but I do see I did a capitalization mistake there, which I now have to fix a billion times. Why? I think we're going to have to debug. Let's debug. Debugger. That's why I pay for the premium, apparently. Okay. There's our points. There's our K. Square of distance to ordered pair is a map. Yep. Oh, square of distance. That's the map to order pair. It's not a distance to somewhere. It's distance to order pair is the key to value mapping. And squares of distances has 0, 0. So it's already... Oh my goodness. I feel so silly. We don't, squares of distances, we don't want to, it doesn't have a length of K. Oh my gosh. Some days I wonder how I even can code. It's points length. Oh my goodness. Okay, so that works. Let's see how much faster that is. So that the refactoring we performed was, instead of using a list of integer to store the squares of distances, we're now using an integer array. So let's see if it's faster than 57. It is faster. That was an improvement. And 30%, a little bit more respectable. Let's try submitting it again. Sometimes, you know, you catch a slightly faster. Yeah, it's about the same. I like to keep a record of the high water mark, you know, how fast it might have gotten. Oops. There we go. So, can we make it faster still? And I'm going to get rid of that code. Map. So evidently, evidently I didn't run into the problem where, I've got one more slot to fill for my k closest points, but I've got more than one available point that it would be eligible. So evidently that wasn't a problem. So that means let's try moving. So I had been checking to see if we reached k points after every point we add, but let's see what happens if we move that out of the inner loop and see if it still works. Okay, let's submit it. So it works, and what that tells me is that it's that k is always going to align on a boundary where we don't have to pick some of the points within that have the same square of a distance from the origin. So at least moving this comparison check, this if, out of the inner block, the inner for loop there, we're not checking it every time. We're not checking it after every single point. We're just checking it after every set of points that have the same distance. Be nice to see a better increase. We'll see 32, a little bit better. Okay, so this is very incremental improvement, isn't it? Okay, is there anything else we can do? I wish I had a profiler for here, for LeetCode. Profiler would actually show you where your code is spending the most milliseconds. I mean, you can see what the hotspots are. I suppose I could take this code and open it up in IntelliJ and run a profiler from there, but I may do that at some point. That would actually be very interesting. Well, let's see, we're at 52 minutes. I probably could go through, it's not obvious to me where the next improvement or optimization would be. So I'm going to call it a halt here. 30, better than 32%, not super great. I like to be in the top half, ideally. But, we did a few improvements. It might come down to I need a better way of structuring the data that I'm storing or approach it differently. And, that's a bigger refactoring if you're changing the actual algorithm that you're using. This, I'll be the first one to say this is kind of a naive implementation. I mean, it's very humdrum and straightforward. But if I were to look at the problem and kind of think about it some more, it's possible there's like a shortcut or kind of a more efficient way of returning the same result. Anyway, I appreciate you hanging out with me today and hope to catch you in the next video. If you want to make sure that you're informed the next time I upload one of these videos, do all the stuff, hit like, hit subscribe, touch the little bell icon, and that'll ensure that you're up to date whenever I post more videos. Feel free to add comments if you have any suggestions or questions about anything that's happened here. And I hope to see you the next time. All right, bye-bye.